All right, so Jakeltrick, what was a combination of cats and dogs that your group came up with that worked? What else you know? Huh? Were you talking with your group to try to figure this out? Okay. Marius, what's the combination that y'all came up with?
16 cats and 11 dogs. No, wait, the other way. 16 dogs and 11 cats.
16 dogs and 11 cats, is that right, Christian? You think so? Okay, let's look at it. So 16 dogs and 11 cats. So what are the things I need to consider to see if this works out?
Space and money.
Space and money, so the startup cost is what you're referring to there? Okay, so space and cost. So let's look at that space. How are we going to figure out how much space this is taking up?
Cats would multiply by 6.
Okay, so like 11, are you doing 6 times 11 or are you doing just like 6 times C in general?
6 times 11.
Okay, so 6 times 11. Those are my cats. Anything else that we need to look at there?
The dogs.
The dogs, so how much were the dogs taking up?
24 square feet.
So 24 times
16.
16. Might want to add those together. Why would we multiply 6 times 11 and 24 times 16? Why would those things be multiplied?
Because each cat requires 6 feet.
Okay, so why would that cause us to multiply though?
Because of this.
See, we want to focus on that idea mathematically. Anytime we're looking at that repeated addition, we're going to multiply, right? That's huge to pay attention to there. And so, how much space are these 11 cats and 16 dogs taking up? Group 1, I thought you already had this worked out.
It's 400.
450 square feet? So does that fit within our constraints? Oh, no. Okay, we're going to come back to that one in a second then. So 16 dogs, 11 cats. I'm going to record that over here and we'll come back to it. Come on, we've been working on this for 2 days. One combination of cats and dogs that satisfy both constraints.
10 dogs and 6 cats.
10 dogs and 6 cats. Let's try that. Okay? So for space, it'd be 6 times... Remember, these are my cats. Each cat takes up 6 square feet. So 6 times 6. And then for my dogs, it'd be 24 times. So how many square feet is that? Thank you.
276.
Okay. 276 square feet. So does that satisfy the space constraints?
Yeah.
Yeah, because they had to stay under how much?
360.
360. Cool. What about cost? How would I represent the cost for these 10 dogs and 6 cats?
6 times 32.
Okay, so each cat took up $32, or each cat pin took up $32, so 32 times 6 for those 6 cats.
80 times 10.
So each dog took up $80 for a dog run, so 80 times 10. So what does that come out to be for their cost? 992. Does that come in under the amount that they had to spend?
Yeah.
Cool. So we have a combination of cats and dogs that are satisfying the space and the cost constraints. Awesome. So let me ask you this. And this is one of the things I was trying to push y'all to do and make sense out of. What is a representation that I can bring order to this chaos of trying to figure out what worked and what didn't work? A table, right?
Yeah.
So one thing I realized later would probably be a better idea. I had some of y'all making one single table that had a whole bunch of information in there. But how many constraints do we have going on here? Two. So how many tables could I use to represent those two different constraints? Wouldn't that make sense? So let's look at our space. We had, and I do want to point this out. When it comes to cats and dogs, does one depend upon the other?
No.
No, they're just kind of interchangeable, right? So why did I put cats down here and dogs up here on the independent x-axis and the dependent y-axis?
Dogs cost more.
Maybe. Honestly, you want to know something a little weird that you just need to be aware of sometimes?
What is that?
I just made a decision. Notice is there really an independent and a dependent variable here? No. So I made a decision to do cats on the x-axis and dogs on the y-axis just so our graphs all look the same. Does that make sense? And if there's no clear independent variable and no clear dependent variable, it is totally okay to just say, hey, I made a decision to put cats here and dogs here. Make sense?
Yeah.
You good with that? Okay. So, but I'm still leaving cats as my independent, dogs as my dependent now. So we looked at 6 cats, 10 dogs, and did that work for the space?
Yeah.
Yes. And for cost, got my cats, got my dogs. Did 6 and 10 work again?
Yeah.
Yep. Notice how I'm just indicating with a quick little check mark that I checked it, that it worked out, right? And so now when I come here to this graph, I'm going to go 2, 4, 6 on the cats, and how far am I going to go up on the dogs?
10.
There's a point. That's clear indication of how many cats and how many dogs that I have going on here. But what was the focus of this? What are we trying to optimize or find the maximum value of for Carlos and Clarita?
Maximum money they can make.
Maximum money that they can make, right? So I still need to check to see what?
Is that the max? The money.
The money, right? How am I going to figure out how much money they're looking at in this case? Come on, group 1, you gave me this option. Didn't we already calculate this?
Oh, you multiply the number of cats and dogs by the money that they cost.
Okay, so the money that they cost or the money they're charging?
Well, yeah, charge.
Charging, right? So for every cat, how much money are they charging for a day?
32.
That's how much they're charging to house the cat?
$8.
$8, right? So $8 per day for boarding. So we're looking at money, so 8 times how many cats? 6. Plus how much for each dog?
20.
Times
10.
10. So how much money are they looking to make? Every single day.
$248.
Mm-hmm. Remember guys, you have calculators that you can use too. And I'm impressed that Jaden did that in his head. But you have calculators you can use. Fun fact, I was thinking about it this morning. These are pretty realistic numbers. My wife and I, we board our dog a couple times a week just so he has, not board him, but he goes to a doggy daycare a couple times a week so he has other dogs to hang out with and play with throughout the day. They charge us $20 a day to send him, which is why we send him twice a week. And no more than that because we don't have that kind of money. We're teachers. But $20 a day for those dogs. If they are doing $8 a day for those cats, that company is making $248 in a single day. And I guarantee you they have more than 10 dogs and more than 6 cats. That could be a lot of money, can't it? This is something realistic to think about and to consider. So $248 though, and I'm going to record that here to indicate how much money that is. But notice I'm creating order out of the chaos by putting into a tabular representation, putting into a graphical representation to understand what is happening. Sound good? Make sense? Okay, so group 2, right? What was a combination of cats and dogs that y'all wanted to use?
20 cats and 8 dogs.
20 cats and 8 dogs. So pit space, cost, 20 cats, 8 dogs. Alright, from there, how much space is that?
312.
312, so 6 times 20 plus, was it 24 times 8?
Yeah.
And so that's 312 square feet?
Yes, sir.
Whoops, not dollars, square feet. Alright, and cost? Well, it would be, how much is each cat gonna cost to start up? How much is a cat pen?
Yeah, I think 640.
Say again?
640.
No, how much is each cat pen?
Oh, 13.
32, right? Times that 20 is the 640, okay? What's the startup cost for each dog?
24 times 8.
It only costs $24. Startup cost,
80.
$80 for each dog run, so 80 times 8.
Yeah.
Notice 32 times 6, 80 times 10, so 32 times 20, 80 times 8. That might be important later. So how much total was that? Was that exactly 1280? That's interesting. So you used up all of the money for that one, right?
Yeah.
Let's look at this problem then. I'm going to use a different color marker for this one since you found a special point that used up all the money. So space, we were good, 20 cats, 10 dogs, no, 8 dogs. My memory is failing me, sorry. That worked on space, cost-wise. Again, 20 cats and 8 dogs, that worked on startup cost. So money-wise, we're looking at 8 times 20 plus 20 times 8, which came out to be how much money?
320.
$320. Man, that's a lot of money. I would love to make $320 in a day. It'd be fantastic. So, 20 cats, 8 dogs, would be here. Looking at $320. Was anybody able to find an amount of money that was more than $320? No? Okay. Let me ask you this then. So we already had this option of 16 dogs and 11 cats. Did that work on space?
No.
Whoops, that was 16 dogs and 11 cats. I flipped that. 11 cats, 16 dogs. That did not work on space. Did it work on the cost? We haven't checked that yet. But did it work on cost? Can someone check it for me? I believe that would be 32 times 11 plus 80 times 16.
It does not work on the cost.
Yeah, how much money is that?
That's, 1,632.
A little bit over the 1,280 that they had, right? Okay, so notice it's important, right? Would they make more money this way probably?
Yeah.
Probably, right? Let's check it out. What is 8 times 11 plus 16, or 20 times 16? What would that be? How much money would they be making there? Whoo! That is more money, but, and this is the issue, this is why we say we have to meet the constraints, right? There are limitations on what they can do. They don't have the space or the money to start here. Maybe if they make a little bit of money and then they expand their business, they could do this, right? But they're not there yet, and so that wouldn't work. That'd be really nice, but it's not working. So 11 and 16 would be here. Notice how that's way beyond these other points that we already have, right?
Put that. Put that down.
Yeah, I will, you can, but maybe put like an X through it, or maybe use a different colored pencil or a pen or a pencil to note it, indicating how it's different. Notice how I'm using, I have one graph, I have 2 different tables, but notice how I'm kind of using different colors to indicate different things. The black was to just indicate, hey, this is within both constraints. I use this blue here because, hey, we used up all of the money that was there. That's special, right? And notice we got more money out of it. I'm using red to indicate something that doesn't work. Does that make sense?
Yeah.
Okay. So what's a different combination of space and cost that we came up with or that we found?
40 cats, 0 dogs.
40 cats and 0 dogs. Let me ask you this. Did that 40 cats and 0 dogs use up all of one of the constraints?
Yeah.
Which one?
Cost.
Cost, okay. So notice 40 cats, 0 dogs. That used up all of the cost, but it met both constraints, right? And so that'd be this point down here. 8 times 40 plus 20 times 0. How much money was that?
320.
$320. Interesting. These numbers that are using up all of one of the constraints are all coming out to be $320. That's a lot of money, isn't it? Right? Do we have any other combinations, right? It doesn't have to get that 320, but did anyone come up with any other combinations of cats and dogs that would represent how much, or a viable number of cats and dogs for these constraints? Any other combinations of cats and dogs? Say
12
again.
cats, 12 dogs.
20 cats and 12 dogs.
No, 12 cats and 12 dogs.
12 dog. Okay. That works for both constraints?
I think so.
Okay. So let's check our 12 and 12. Right? If you do 6 times 12 plus 24 times 12, what do you get? Remember, so if you're doing 12 and 12, space was 6 times the number of cats, so 6 times 12, and then we're also doing 24 times 12.
$504.
Say again.
504.
6 times 12 plus 20 times, no, 24 times 12, bud. That's still not 24.
Oh, I'm so down. I'm sick.
24 times 12, right? There's 24 square feet for each dog times the number of dogs you're saying is 12.
Oh, 280.
Okay, so that, now, that is just for, it's 280? 24 times 12. 288.
Oh, yeah, 288.
That number matters, okay? So, but you still haven't considered the cats. So how much total space is it when we consider those cats? Guys, remember, can you put this whole thing into your calculator all at one time?
240?
No.
Too much.
It's actually not too much here. If you check this whole thing, it is 360 square feet. So is that good?
Yeah.
But we still need to check our cost. 32 times 12 plus 80 times 12. What does that come out to be money-wise? We got calculators. Let's stop sitting around and doing nothing. Let's pick it up. Let's do something.
$13.44.
Is that okay? Do they have that much money? No. So 12 and 12 was okay, but if I did 12 and 12 here, that did not work out. Now, it was okay on space, but it wasn't okay on money. Was it close though?
Yeah.
Yes? What could I probably do then to get it within the right amount of money?
Or take something down.
Take something down, right? You want to take down the number of cats or the number of dogs?
Dogs.
Okay? So how many dogs are you thinking?
3.
3?
2. Oh, yes, 2, maybe.
Let me ask you this. Are you far away from the
Take
1,280?
down 3. Like, take it down.
Oh, take it down 3? Okay. We could take it down. Let's take it down 2. 12 and 10. Do I even need to check the space? No, space is already good, right? How much money is it going to be though? Let's check to see if that works.
274.
32 times 12 plus 80 times 10?
800, oh no, 1,804. 1,084. Thank you.
1,184.
Yeah.
So is that within the constraints?
Year.
Yes. Did it use up all of the space or all of the money?
Neither?
Neither, right? So 12 and 10 work, but it doesn't use up all of the space and all of the money. Any predictions about whether it'll get to this 320 or not?
It won't.
It won't. Why do you know that? It did not max out the space or the startup cost, right?
Yeah.
You gotta spend money to make money. You gotta use up all your resources if you want to make the most amount of money. But I want you to notice this. Is this table helping us make order out of the chaos of all these words?
Very much.
Very much so, right? This graph is helping us see what kind of points are going to work and which ones aren't. Notice I'm using these blue points to indicate, hey, this is the most money that it'll make. Notice these ones that are in black are a little bit lower. These ones in red are a little bit more. You're creating order out of chaos. Have we been able to identify values that satisfy the constraints of a word problem? Are we getting better, hopefully, at creating multiple mathematical representations? By the way, if you didn't have the tables, please make the copy of those tables down as well. You're supposed to record all this information to refer back to later. Here's your homework, 5.1 set, numbers 5 and 6, just 2 problems, right? Tomorrow we're going to work on test corrections, and if you have not taken the test yet, you're going to finish or take the test. Okay? Have a fantastic rest of your day.